This video is about how to represent decimals using base 10 blocks. The typical way that we show children how to use base 10 blocks is using this 1 cube to represent 1 or a unit, this 10 to represent, this rod to represent 10 because it's 10 cubes here, and then this 100, which also is called a flat because there's 100 cubes here, and it would take 10 100s to make 1000. So this is your thousands representation. So this is what we usually use for whole numbers. When we begin to look at decimals, you flip it in the reverse order. So this would actually be one whole. This would represent 1. As a decimal point, it would be written as 1.0. For a tenth, the typical flat would be a tenth because it would take 10 flats to make one whole. And this would be represented as a hundredth, and this is your decimal representation. It would take 100 of these to make one whole. It would take 10 100ths to make 1/10. And then you have your thousandths. This used to be the unit. Now it would take 1,000 of these to make one whole. And this helps children see what the decimals and whole numbers can represent physically. They can manipulate them, create their own decimals using these base 10 blocks. For example, if we wanted to make a decimal, you could have the students practice using the blocks, and they can write the decimal in standard form, expanded form, and word form. So a good modeling task for base 10 blocks would be to create different decimals with students, model it, and also help the students practice by making up their own decimals, writing them in standard form and expanded form and word form, and using the base 10 blocks to build the conceptual knowledge. For example, this again will be one whole. So if you have 2 of these, there will be 2 wholes, and 2 would be the digit in front of the decimal point because it's a whole number. As we look at the flats, they would represent the 10th place because again, it would take 10 of these to make one whole. So if you have 3 of these, then that would be 3/10, and you would put 3 in the 10th place, which is directly behind the decimal point. Next to that place value is the hundredths place, and we have 5 100ths, so that would be 5 hundredths, and the 5 would go here in the hundredths place. And then we have 3 thousandths because it would take 1,000 of these to make one whole. So if we have 3 of these, that would be 3 thousandths. It's important for students to use hands-on tasks with base 10 blocks so they can really get a better understanding of how much a decimal is worth, so that they understand that these are parts of a whole. If these place values are less than one whole, everything to the right of the decimal point is less than one whole. Everything to the left of the decimal point is greater than one whole or more. So the more that they can see that, visualize it, manipulate it, the better they will understand decimal place value. In my experience, there's been students that think that this digit is the greatest, or the decimal that has the most digits behind it means that it's greater. But if they can't physically see how small the thousands place is and how many that you would need 1,000 of these to make one whole, that they get a better understanding of how to compare decimals, how to label decimals, how to read and write them.